This is lesson 81, BHDL example 53. And in this example, we'll see how to generate an arbitrary waveform. Recall this divide by 8 counter. Remember, we had the 3 bits which generated Q2, Q1, Q0 that counted from 0 to 7. So the idea is to use Q2, Q1, and Q0 as inputs to a combinational circuit that will produce the arbitrary waveform. Here's an example. Suppose we make the output Y 1, 1, 0, 0, 0, 1, 0, 1 as Q2, Q1, Q0 count from 0 to 7. Well, then the output will be 1, 1, and then the waveform will go 0, 0, 0, then Y will go to 1, then 0, then 1, and then when the counter repeats, this waveform will repeat. So you can generate this arbitrary waveform by just making it go high and low as you want here. Of course, to get the logic equations for Y, you just draw a Carnot map with the inputs Q2, Q1, Q0. In this case, there are these 4 minterms. We draw the 2 circles. We see that Y is not Q2 and not Q1, or Q2 and Q0. So that's the idea. Let's take this example of International Morse code. Here's the Morse code. Let's take A, for example. Suppose you wanted to produce a dot dash. Well, here's a dot would be 1 bit, a dash 3 bits. So this would be the output A. So we'd have these 4 minterms shown here. You draw the Carnot map, and you see that the logic equation is just not Q1 and Q0, or Q2 and not Q0. So now we know the logic equation for A, and we just need to make the 3-bit counter. So we have a 3-bit counter, and the outputs Q0, Q1, Q2 go into this combinational logic circuit that produces A. Let's write the BHDL program for it. Clock clear in, A is out. We'll make the signal Q the output of the counter, and we'll just put our 3-bit counter in this process. Is the asynchronous clear on the rising edge of the clock? Q is Q plus 1, like we've seen before. And then we just set A to not Q1 and Q0, or Q2 and not Q0, the results from our Carnot map. And here's the simulation, and sure enough, we generated dot dash, dot dash. So using this technique, you can produce any arbitrary waveform.